equations and how to graph them and slope and the types of equations that we're going to be dealing with that are linear equations. And this is linear equations in two variables generally. So 3-1. That's better. What do they call it? They call it graphing linear equations with two unknowns. They have such long titles. We might as well just describe the entire chapter and be done with it. But basically, it's linear equations again, but it's unlike the linear equations that we had before where we were solving for a variable and we got some kind of nice specific answer. This is going to be more a general solution type thing. So before we start graphing, you all learned how to deal with a number line. You know, 0 is here, and this was 1, and this is 2, and this is 3, and this is -1, this is -2, and this is -3. What is the purpose of a number line? It shows us direction. And if we plot points on here, like if I say x is equal to 3, we would put a point at 3, and it would become its, well, location on the number line. And if we plotted the point at -2, we can compare the location between -2 and +3 as a distance on the number line. So it becomes basically a location in one space, which is kind of boring. Not many people are one-dimensional in nature. So what they do to talk about like this floor and your seating arrangement, your location in this room, they add in another number line and they pass it right through 0. And this is -1 because we're going down, -2, -3, and up here is +1. Oops, get rid of that string bar. +2 and +3. So they throw two number lines at you, one going horizontally and the other one going vertically. And what this allows you to do is to find a location in a plane, like the floor or a seating chart in a room. A couple little points about this. The intersection of these two number lines, what's it called? Anybody remember? I know I'm getting really basic with this, but this is important to understand why this actually works. Anybody know what the intersection of the two number lines is called? Origin. And it's called the origin because that is where you're going to start everything. Origin. Also known as 0, 0. Now, if you're plotting just on the blue axis, all you'd have to say is x equals 2, x equals -3, and you could find the location. And if you wanted to plot on the vertical red one, you could say y equals 2, y equals -3, and you could plot a location. But if I'm trying to find a point that is over here, to get to that location, I have to have a combination of the x-coordinate and the y-coordinate. Remember, this is called the x-axis, and the red one is called the y-axis. The marker's 9. Now, what would be the location of this point approximately? On the x-axis, where would you go? -2. So that would take you along the blue line, 2 units. And then on the red axis, down 3. So to get down low enough for this point, you'd have to go down 3. To get to the left, you'd have to go -2. And we put it in the order of alphabetical. It would be -2 for x, -3 for y. And it just becomes a location in the plane, Now, where do we live? Do we live in a plane? No. Not plane like airplane. I'm talking, plane, flat surface. What do we live in? 3 dimensions. 3 dimensions. So, how many axes would that have? 3. Where would the third one go? Well, in 3 dimensions, there's up and down. There's left and right. Back and forth. So the third axis would come right out at you. It's kind of cool, but you don't have to worry about that. But there is a way of getting into the 3rd dimension, and by the way, higher, which makes no sense to anybody. 4th dimension. What's that mean? The only 2 points that I'm really, really worried about on this axis is something like this point here. What is the coordinate of that point right there? It's right on the red axis, the y-axis.
0, 3.
0, 3. And the other point I'm really concerned about is something like a point on this axis.
-2, 0.
-2, 0. A lot of people get the order of these two messed up. They put the 0 in the wrong location. So you have to remember, when you're dealing with coordinates, it's always left, right first. It's always moving left or right. And the second motion you do is up and down, because it goes in order as x comma y. So when you think of these coordinates, this is a left-right motion. And this one here is always up-down. And that's the only way those will go. So that should kind of lose the confusion that if you go up, then that's affecting the second coordinate and not the first one. So if you're not going left and right, that just becomes 0. And if you're not going up and down, that second coordinate has to be 0. So those are the only two that usually mess up people. The one that messes me up, I always mess this one up. If I have -2 or -3, -2, like this point here, for some reason, and you'll see me do it eventually, I'll go left and up, even though I'm supposed to go left and down. That's one of my major mistakes. I don't know what it is about that. Both negative, but for some reason I like going left and up, or yeah, left and up. But it should be 3 to the left and 2 down, so it should be down here. But eventually you're going to catch me doing it the wrong way, and you'll have to correct me. I think it's part of my dyslexia, I know. Okay, so when we're talking about linear equations and two variables, there is the general linear equation. And this book, for some reason, loves this thing. When you get to college algebra, we pretty much drop this off the map and really don't talk about it too much. But here, they like talking about it a lot. So the general linear equation looks like this, where capital A, capital B, and capital C are real numbers. We'll call them specific. X and Y are also real numbers, but when we talk about capital A, capital B, capital C, we're talking about like 2x plus 3y equals 7. So A, B, and C become real numbers. So we might be talking about something like 2x plus 3y is equal to -6. And we have to talk about graphing this. And there's like 3 or 4 different styles of graphing this. I'm going to show you every single one of them because they each have a place in later math. One style only works for lines. Another style works for any type of equation you can write with powers and absolute values and square roots. It really doesn't matter what it becomes. So I'm going to start with the one that works for all equations, and it's called table. Now, if you're going to work with a table, this technique works for everybody. Works for any equation you can imagine. You can always pick values, plug it in, and see what comes out of it for any type of equation. So this is not restricted to just linear equations. For the table to work really, really well, the best thing to do is to take this equation and either solve it for x or solve it for y. Generally, you solve it for y. Generally. You can solve it for x. It won't hurt anything, but later on, it'll always be y. So let's go through and solve it for y. So 2x plus 3y is equal to -6. The variable we're concentrating on is this y. By the way, this is part of your test. You still have to be able to solve for any variable I tell you to solve for. How do you solve for y?
Subtract 2x.
Subtract the 2x. So we're going to get 3y is equal to, generally you want to put the x first, but it really doesn't matter. But later on, again, I know what's coming, you want that x first. And then to solve for y?
Divide by 3.
Divide everything by 3. And I'm going to do each an individual term. So this will give us y is equal to negative 2/3 x minus 2. All right, so that's a nice little equation solved for one of the variables. Again, if you feel like it, you can solve for x. Like if x is easier to solve for, and you're doing a table value, just solve for x. It makes life a little bit easier. All right, now we're going to do a table, and the setup for that generally works out this way. X goes here, y goes there, and what y is equal to goes here. Negative 2/3 x, what was it, minus 2? Minus 2. Might as well give you some heads up on some naming of these things. In this setup, with y on the left and x on the right, we're going to call x independent. It becomes known as the independent variable. In other words, it can be anything you want it to be. Any number you choose. But once you choose what x is equal to, you're going to plug it in here, you're going to do a calculation, and that fixes what y can equal. It can't equal anything. It has to be dependent on what you choose x. So y has a nice name. It becomes known as the dependent variable. So x, in this case, is the independent variable. Y is the dependent variable. Now what happens if I solve for x? Then they switch around. Then x becomes the dependent and y would become the independent. You can choose anything for y. But generally, we choose x to be the independent and y to be the dependent. Okay. So what number do you want to pick?
47.
Good Lord, I want to fit it on the graph paper. I want to keep it at least within -6 to +6 on both axes. Do -3. Now, why would you choose -3? Because that's the denominator. You want to keep this thing in multiples of 3. Otherwise, you're going to be dealing with a bunch of fractions. And I don't like dealing with fractions. So if we take -3 here, we're going to do a substitution. So you're going to get negative 2/3 times -3 minus 2. I highly suggest that you, when you do the substitution, it's another thing to get used to, and I know where it's going to eventually end up. Replace the variable with an empty set of parentheses and plug the number into that space. Don't write it like -3 or negative 2/3 times -3 minus 2. You'll still get the right answer. It's just later on, the parentheses become a little bit more necessary because they'll have exponents, it'll have some other weird stuff going on, and parentheses keep things rather clear. What's negative 2/3 times -3? Which one?
2.
2, positive 2, right? So we're going to get 2 minus 2, better known as? 0. So this gives us a coordinate, -3 for x, 0 for y. What axis is this on? It's on the x-axis. It's just like this point here. If you have a number for x and a 0 for y, you're on the x-axis. It actually has a special name. We'll talk about that later. All right. What's the next value you want to pick? Fine, 0. Negative 2/3 times 0 minus 2. Of course, anything times 0 is 0. That's a 0 multiplication property. 0 minus 2 is?
-2.
What property? Identity. And this becomes -2. And we get this coordinate 0, -2. 0 for x, -2 for y. What axis is that one on?
Y.
That's on the y-axis. And it has its own little special name. We'll talk about that in a second. What's the... Now, hold on 1 second. I told you that this was a linear equation. Linear relates to what kind of picture? A line. How many points do you need for a line? No, you only need 2. The definition of a line is that it goes through any 2 points and you get a unique line. But why do you pick 3? No, you only need 2. So why were you always taught to pick 3? You can check your work as the big one. And also you can draw a better line. Sometimes the points are way too close together and it's really hard to draw a line. Plus, you might want to be checking your calculations. Because if you graph 3 points and one of them is off, are you ever going to get a straight line out of it? No, you're going to get a triangle. So when you choose that third one, it's not necessary. It's just called the checkpoint. What number you want to pick? Boring. 3. Negative 2/3 times 3 minus 2. Again, the 3's cancel out what property? When you say cancel out, there's only one property that works. But it has 2 operations, addition and multiplication. Nope. Yes. Whenever you say the word cancel, you have to think inverse identity. It's a mixture of both of them. So the 3 over the 3 becomes 1. 1 times negative 2 is? Negative 2. Negative 2 minus 2 is?
Negative 4.
Negative 4. Please don't say 0. So we're going to get this coordinate 3, comma, negative 4. Yay. So we have 3 points of the line. And then we can graph it. I do have graph paper. I did print it off. I just didn't bring it. So it's sitting on the printer right now. So for now, we're just going to have to sketch it. If you want to draw nice lines, just get a short little 6-inch ruler, 1/2 foot ruler. They're nice and easy to carry around. Credit cards usually work really well.
Can I borrow yours?
No, there's no money on it. All right, now we're going to scale this according to the numbers here. So the biggest we have is 4. So I'm just going to go 4 in every direction. So this would be positive 1, positive 2, positive 3, positive 4. Here's negative 1, negative 2, negative 3, negative 4. Try to keep the spacing if you're sketching this by hand even. If you start changing your spacings between your numbers, your graph is going to look a little wobbly, to say the least. And then 1, 2, 3, 4 up, and 1, 2, 3, 4 down. You guys will come in, but I gotta grab the apps. All right, and then just plot your points. So let's see here. Negative 3, 0. Where do I go? To the left 3, and then where? Nowhere. Stay right on the axis. And plot that point. 0, negative 2. Just straight down 2. Nice squeaky marker. And then positive 3, negative 4. Right 3, down 4. That'd be right about here. Now that I look at my picture, I didn't scale it very well. That's where graph paper comes in handy. It should look rather straight. I don't see it being straight. Now, here's the thing. This is a little theoretical, so if you don't mind, just follow along with my logic a bit. What were you taught to do next?
Draw a line.
Why?
Because I was told to.
Because you're told to. And that's a dangerous thing, because then you're doing something, but you don't understand why. So are these the only 3 points that this equation can come up with?
No.
No. How many more points are there?
Infinity.
An infinitude of possible points. We could have chose negative 3.1, negative 3.2, negative 3.3, negative 3.3333, 999994444. I mean, we could have come up with any numbers possible. And what's the assumption that's going to be true for the locations of these points? Like, for instance, if I chose negative 1, would the point be up high? No. It would be where? Down here? Way down low? No. Where would it go?
Negative 1 on the x-axis?
Yeah, negative 1 on the x-axis. Where would the y value be?
Negative 1.
Negative 2 be down here?
Negative 1.5.
Okay, now give me a location. If you were going to say, where is this point going to go, it would be between where?
Between these two.
Between those 2 points. So when we figure out what negative 1 is, it more than likely is going to land like right here, because it has to lie on a line. So when we plot all these points, what we find is we get all these points in between these red ones, and they would follow each other precisely, which is kind of cool if you think about it. There's an infinite number of points between any 2 points that you pick. So what happens then is you fill up a line, because a line is a representation of an infinite number of points. And that's what a line is. You're saying, if I pick this value right here, whatever the heck it is, negative 2 point something, 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 that the point that it generates is always going to be between two of the other points that I already generated on that line, which is kind of cool if you think about it. So when you draw this line, you're actually drawing an infinite number of points, an infinite number of dots. Now, graphing calculators, y'all work with a graphing calculator? No. Do they draw lines? No. They draw a bunch of points. What they do is they plot a ton of points, and those plots become the graph. It doesn't graph a line at all. It just graphs a lot of little points. A lot of them. And that's how graphing calculators work. They actually use tables to graph their stuff all the time. Every graph that you can put into them. Graphing programs, graphing calculators, any place where you can type in information and get a graph out of it, it plots a bunch of points. All right. So that is the table format. The other one has to do with when you talk. Oh shoot. When you talk about a line graph, or any graph for that matter, let's say we have a line that goes this way. Get a new red marker. It's intersecting the x-axis here at that point. And it's intersecting the y-axis up here at this point. Give me a reasonable coordinate for the one that crosses the x-axis. What would be a reasonable coordinate? Just make up one.
3.
Positive 3?
Negative 4, 0.
Negative 4, 0 would be good. Because it's to the left, it has to be negative. Because it's on the x-axis, the y-coordinate has to be 0. What would be a reasonable coordinate for the one that crosses the y-axis?
0, negative 3.
No, because negative 3 would be
Was 0 positive 3?
0, positive 3, because you're going up. Okay. These 2 points are actually extremely important for all other graphs. Well, semi-important for linear graphs, especially when we get into higher level math. But for most other graphs, these 2 points, or these types of points, are extremely important. Especially, which one do you think?
Negative 4, 0.
Negative 4, 0, you think?
Mm-hmm.
Anybody else?
Which is that?
Which one of these two are more important for graphing?
0, 3.
Do you remember graphing lines at all?
Not really, but
Seriously.
the X. The X.
It's the y for lines. Most people would say the y-intercept, this point up here, is more important than this point down here. But the truth of it is, this one's more important. This one is called the x-intercept. For most equations that you're going to graph, the x-intercept is much more important than the other one. But for lines, for some reason, the importance switch. For lines, this one's more important. And this one is called the y-intercept. And basically all these are is, where does your graph cross the x-axis? That becomes your x-intercept. Where does your graph cross the y-axis? And that becomes your y-intercept. So it's kind of, logical in its way. And all x-intercepts have a y-intercept, or a y value of 0. And all y-intercepts have an x value of 0. The other coordinate could be anything. It can be absolutely anything. So when you have a 0 and a coordinate, you only have 2 choices. It's either an x-intercept or it's a y-intercept. You have to figure out which one. So we can graph lines just with an x-intercept and a y-intercept because it gives us 2 points. And you don't have to go looking for the third one when you usually do intercepts because the errors are a lot less likely. Calculation errors, that is. Let me show you a possibility. And take care of 2 things at once. For example, 5x minus 3y is equal to 1,500. This is where intercepts become actually a nice method for graphing. All right. Let's start by doing a table and see what happens. Let's see what happens. And we're not going to finish it with the table. We're just going to start it. So the first step to start making this a table,
Show your lines.
solve for
Y.
y. It's like a hidden direction. For this chapter, pretty much the direction is always going to be solve for y. You know, kind of in the background. You just have to remember to do it. So if I solve for y, what do I need to move?
5x.
That 5x. How do I move it?
Subtract it out.
Subtract it over to the other side, so it becomes negative 5x. And that's a positive 1,500, or 1,500. Okay. Then what? Divide by negative 3, so I'm going to divide him by negative 3. Might as well divide this guy by negative 3 and distribute it over here to this guy. That's the distributive property. I'm trying to remind you of the properties because I know what's coming on the test. So, what happens to this one? And the property of cancel is? Inverse. Multiplicative inverse in this case. So we're going to get 1 times y, which is that identity is y. Negative 5x divided by negative 3. Positive 5/3 x. Positive 1,500 divided by negative 3. Minus 500. Okay. Now, if I was going to do this with a table, it's set up perfectly fine. What kind of numbers would you choose again? No, not any. If you choose any, you start getting fractions and it gets messy. Look at the fraction. What's in the denominator? 3. So you want this number to be multiples of the denominator over here. So let's start a table, but I'm not going to finish it that way. I just want to show you what's wrong with it. X over here, y over here. In here goes 5/3 x minus 500. X is called the independent variable. Y is called the dependent variable. Okay. Yes?
Do you always, when you set up a table, say that you have to have a negative
I highly suggest picking negatives and positives just for behavior purposes, but sometimes these things are so weird that you might have to pick all positives or all negatives. For instance, if your graph was over here, picking positive values would give you points that are way, way low, but picking all negative values would keep the points kind of around the axis. So it depends on where the line is. If you pick 3 here, you're going to find that this number is going to be way, way low, and that's one of the problems. So let's say we pick 3, and then we get 5/3 x, which happens to be 3, minus 500. What happens to the 3's? Property? Inverse, and identity. And we're going to get 5 minus 500. What's 5 minus 500? Negative 495. Ooh. So that means we have to go 3 to the right. Negative 495. Yeah. Okay. So what other number do you want to pick? 0. Boring. And we're going to get 0 minus 500, which is negative 5. That's even further down.
Negative 30.
That would be even further down. Negative 30. You pick negative 30, you're going to get 5/3 of negative 30 minus 500. 3 goes into 30. 10 times 5. It'll be negative 50. Minus 500 is negative 550. Hey. So how am I going to graph this one? I need to graph it. I need to show what this line looks like for all its possible solutions. So I'm going to set up the y-axis and the x-axis. They go off to infinity in both directions. How am I going to graph this picture? Am I going to mark the x-axis 4 marks, 4 marks, 4 marks, 4 marks?
Yes.
No. I need to get up to negative, or down to negative 550, negative 500, negative 495. So one thing you could do, you could take the x-axis and draw it actually a little bit higher if you want. Or you can center, it really doesn't matter, but you know your values are going to be all low. We're going to have to scale this picture a little strange. So when I make my marks going down, they have to account for hundreds. And then the points are rather close. So one way of dealing with it is, let's see, we have to go down to 550. Oof. So here's negative 250. Why not? Here's, well, maybe not negative 250. What would be a better number?
Could do it like 75 or something.
Well, I was thinking 100. 100 would probably work. Let's make that 100. Negative 100. If I made it, this number sucks. If I make it at 250, I would only have 2 marks here, or maybe 3. So let's try negative 100. Negative 100 is here. Negative 200. Negative 300. Negative 400. And finally, way down here, negative 500. And then maybe further down, negative 600. And I'm just trying to show you why this isn't going to work out really well. It's not because the numbers here are huge. It really isn't.
And nine ain't gonna really go that much.
It's not going to change much, no. My other values are 3, 0, and, well, unfortunately, negative 3 or 30. But I'll just do 3 and 0. So, excuse me, 1, 2, 3. So at 0, where are we?
Yeah, the origin.
Well, no, I'm at 0 for x. Y is equal to negative 500. So you go straight down 500. That's not a bad point to plot. That was actually kind of easy. The problem is, when I go over to 3, where do I plot? Negative 495, which is right about here. The line almost looks horizontal. So the scale on this picture is not working because the x numbers are too close together and the y values are very, very, deep into the problem, and it separates it out way too much. So there's got to be a better technique than to graph it with a table. Those numbers are just too different. Too different. So let me show you a new style. A new style would be this. We're going to graph by intercepts. And for this type of problem, it's actually a better way of doing it. Because then the picture actually has something to look at rather than this, which doesn't look like much. So if we graph by intercepts, let's do the same problem. It's 5x minus 3y is equal to 1500. Okay. And if you're going to graph by intercepts, you don't need to go solving for x. You don't need to be solving for y. What we're going to do is just set it up in intercept language. So the first one I want to find is the x-intercept. What is special about the x-intercept? You might have to look back in your notes. What is special about the x-intercept?
Starting point.
No. No, it has no slope. It's a point. It can't have slope.
Is it dependent?
It's the dependent variable, but if you're an x-intercept, what's special about it? This is important. Go back and look where I wrote x-intercept and what the coordinate was that looked like the x-intercept. What has to be true all the time? What is it?
The 0, are you talking about?
Yeah, the 0. Which one is the 0?
Y.
The y. So if you're looking for an x-intercept, your directions are let y equals 0. So if I ask you for an x-intercept, the hidden direction, it's actually a hidden direction. The hidden direction is let y equals 0 and solve for, well, the other variable. So we're going to write down our equation, 5x minus 3, but since I'm substituting for y, I want to replace it with an empty set of parentheses, is equal to 1500. Okay. What goes in the parentheses? 0. 0 times 3? Well, negative 3.
0.
Is 0. 5x plus 0?
5.
5x. And this is going to equal 1500. And how do I solve for x? Divide both sides by 5, and we get x is equal to 300. Now, what is this as a coordinate on a piece of graph paper? I always go back to coordinates at the end. So what is the coordinate of this point?
300, 0.
300 is x, and 0 is the y. Whenever you're dealing with graphing, if I tell you what x is, you better go looking for y. If I tell you what y is, you better go looking for x. That's how double variable equations are going to work. The other thing we need to find is the y-intercept. How do I find a y-intercept?
X is 0.
You're going to let x equals 0 is the hidden direction. So if you're looking for x-intercept, you choose y equals 0. If you're looking for a y-intercept, you choose x to be 0. And then you set up your equation again. So it's going to be 5 times x, but we're substituting for x, minus 3 times y is equal to 1500. I highly suggest don't even worry about plugging the 0 in. This format where you write everything down first and then go back to the substitution is just a method of not making silly mistakes. What goes in the parentheses? 0. And then 5 times 0? 0 minus 3y? You almost said 3y. Negative 3y is equal to 1500. Divide both sides by negative 3, and we get y equals negative 500. We already knew this one, but I wanted to go through the process. So what coordinate are we talking about there? 0 for x, and negative 500 for y. And then when we graph this, we're only going to graph 2 points. And the scale on it is actually very similar. The scale for the x-intercept is hundreds. The scale for the y-intercept is also hundreds. So this is going to look a lot better than my original picture. So what, we got 500? So I'm going to go 5 in every direction. 100, 200, 300, 400, 500. 100, 200, 300. How far do I have to go on x? Not that far. And then y, 100, 200, 300, 400. Up here, 500. And then down, negative 100, negative 200, negative 300, negative 400. I have to go down a little further. Negative 500. Now, when you're changing the scale like this, you have to indicate your ticks representing something. And if you just show 3 ticks and 300, then it's assumed that each space is 100 away from each other. If you show 5 ticks and a 500, then each space is also 100. So you have to show some kind of value. You can't just tick and plot points and all that fun stuff. Negative 300. All right. And then plot your points. The only 2 points we have is 300, comma 0. Where does it go?
To the right.
To the right 300. So 100, 200, 300. Plots right here. Nice little x-axis. 300, comma 0. Where is 0, negative 500? Straight down. Right here. So this is 0, negative 500. And like I was saying earlier, you really only need 2 points to draw a line. This line looks something like, let's see if I can get it to go right. I missed it. And closer. Which one's which?
Draw a segment first and then just continue the rest of it.
I'm usually good at going straight through, but my eye's off today. So you get this nice line, and it goes through these 2 points. And if you look at it, you can kind of get a good feeling of what this kind of line is doing. This line over here looked almost horizontal. All lines are straight, but it's horizontal. It's almost flat. Or this line is actually showing off some great, if you had to climb this thing, it would be quite quite difficult. If you had to climb this thing, it would take you, it'd be like walking across this floor. How exciting, boring. But this kind of shows you a better information than this first picture we came up with. This shows you really what's going on with the line. So when you start dealing with bigger numbers, intercepts are usually the way to go. If it's small numbers, generally you want to do a table and just plot a few points. All right.